Hi everyone, welcome to SQLoL. Today, we are going to attempt 3 challenges in the SQLoL. So now, let's head on to the challenges of SQLoL. Within the challenges, there are a total of 13 challenges to attempt. We need these 13 challenges because challenge 0 has been challenged. So we are not going to be doing challenge 0 today. Instead, we are going to continue off and do challenge 1, 2, and 3. So now, let's head over to challenge 1. Let's just go through the challenge 1, SQL Injection 101. The objective is fairly simple. Identify the table that contains the Social Security number, or SSN in short, and extract all its information. A few hints is given in the challenge. Firstly, it is a select query. Next, the injection area is at the where clause. There are no sanitization, and all errors are shown, including the query itself. Therefore, what we are going to do as a tester will be that we are going to know what query are they going to use in their backend. So in the injection string over here, what we are going to type is this particular string, single quote, or 1 equals to 1 hash. What this means is very simple. Because the injection is at the where clause, the single quote will close all the query that is existing at the front. Because when you are doing a where clause, if you are not doing a prepared statement, you are just concatenating the string together. It means that when I actually put this single quote, whatever criteria that you have set will be a blank. Then I uses the all 1 equals to 1 hash. What it means is that 1 equals to 1 always return a true. So since they return a true, it will actually return every single record in the table itself, or the column that is being queried. The hash sign will actually means that I comment off every single other query that is beyond the hash sign. So now, let's just try to inject. And we can see over here, we have 5 results in total. And all these are the username from the user table, because our where statement, where username equals to, is actually blank, or 1 equals to 1, which is always true. That's why this is actually from our username table. Sorry, user table. So now, as an investigator, or rather a tester for this particular database, we don't know what is the database structure, which means this is a black box testing. So what we are going to do is we replace whatever that is in here as our injection code. So after doing a bit of Googling and searching on the net, we understand that this particular database, okay, can be any database. But most of the time, a lot of companies are actually using MySQL, which this particular database is MySQL. So what we are going to do is we are going to query to see what other tables are there in this database. So now, the query to actually pull out the data of the table names within the database is select table name from information schema. So let's just type it in here, select table name underscore name from information underscore schema dot tables. Okay, but this code will not work because one single select statement cannot have two select. One query cannot have two select statements. So what we are going to use here is what we have learned in our ethical hacking and defense. We're going to use union. Okay? Because of how the query is, union only can collect the same amount of columns as the first statement. So we can see from the first select statement is that it selects username from users. That means to say there's only one column being selected. So at a single point of time, only one column can be selected from the other union table. So what we are going to do now is that we are going to run this particular command because we have already selected that table name is going to be the column that we are going to pull out from the table information schema.tables. So now let's inject it. And we can see that there are a whole bunch of table names that comes out, although it has been tagged under the username. That's because we are actually selecting username from user. Therefore, the column, when it actually comes out, is actually classified as username. But the data is actually from table name. So now, those tables that are at the top is not so interesting, because normally it's the system tables that are all at the top and user created table at the bottom. So let us go right down to the bottom of the whole result. And we can see that there are two tables in particular that we might be interested in. Firstly, the last table shows users, which is what the first query is selecting at. Select username from users. The other one is SSN, which is commonly known as social security number. That is the table that we are going to query in order to pull out all its information. So now, what we're going to do now is that since this is a black box testing, we don't know what other columns are there, since we already know that there is this table called the social security number or SSN, but we don't know what other columns are there in the SSN table. So what we are going to do now is that we are going to investigate what other columns are there in the SSN table. So we are going to remove whatever that we typed previously. Okay. After a bit of googling on the net and looking at cheat sheet for SQLi, which is readily available on the net, we understand that for my SQL tables, they all consist of this particular table that contains the column name, which is the table is actually information underscore schema dot columns, and the column name is column underscore name. So in order to select a particular table and display all the table names, all the column name that is related to that table, we need to include a where clause, and we need to state which table we are pulling out from. So what we're going to do is now we select column name. Okay, this is a system generated table, so all the column name are actually system generated. There is no change unless the administrator actually attempt to change them, which is normally not the case. Okay, and from information underscore schema dot columns, where table name is equals to SSN. This will pull out all the column names that is related to the table SSN. So we're going to inject it, and here we go. We have two results coming back to us, name as well as SSN. Since there are no ordering method that we are going to use in this particular union query, whatever that we query is actually organized according to the index in the database itself. So we can see here that we have name and SSN. Getting the SSN alone has no meaning to it because it doesn't identify a single person. It just means that you have this social security number, but you can't identify whose social security number it is. So what we are going to do now is that we are going to pull out the data from the SSN table, but we are going to pull out the name column first before we pull out the SSN column. So we are going to select name from SSN. So you can see now after we inject the code, the result is very different from when we are pulling out our username from user in terms of the orders. The name wise is exactly the same, it's just that the order has been changed. Basically what it means is that this is actually going by the index order and not other orders that we might have set. So that means to say, when we pull out our SSN number later, or rather now, it's going to tally with the name that is shown here. The first SSN belong to Wendeck, second SSN belong to Herb, third SSN belong to Peter, fourth SSN belong to Chang, and fifth SSN belong to Slap the Bag. Okay? So we are going to inject this code. And we can see over here, 5 SSN number coming out to us. So when we match the name to the SSN number, we actually know who has what SSN number. This particular matching will be actually shown in our report. Hi, welcome back to SQLoL. Now we are going to move on to challenge 2, failure of quotes filter. So over here, the objective of this task is exactly the same as task 1, which is actually to retrieve the table that all the data in the table that contains the social security number or SSN. So there are a few hints given to this challenge as well. Firstly, it's the same thing, which is a select statement with the injection being at the where clause. But this time, it's a bit different. There is sanitization. All single quotes are removed. Meaning to say we can't use anything that has a single quote. Because once we put single quote, it will actually remove every single quotes that we have. The error as well as the query will be shown to us as well. So let's just now try what is actually going on in the code. Although single quotes are removed this time around, what we are going to do is very simple. We'll run the same quotes again. So now we are going to inject the query. So you can see here, after we inject the query, we have an error. Error in SQL syntax. The syntax is wrong near the or 1 equals to 1 hash group by username, order by username in ascending order. So now let's just take a look at the query over here. It is select username from user where is admin equals nothing or 1 equals to 1 hash. That is what we just key in, but with the single quote being removed. Group by username, order by username, ascending order. So now we can see from here is that most likely this particular syntax, or rather this particular query, is trying to expect an integer because there are no quotes to actually accept strings. So what we are going to do is we are going to replace the single quote into something like, for example, 1, 2, 3, 4. Okay. Then after that, we just do an inject, and we have our result coming back. because where is and min equals to 1, 2, 3, 4, which most likely is never the case, or 1 equals to 1, the 1 equals to 1 where it returns true is ren. Therefore, returning every single record in the username table again. So now we can see that it is expecting an integer. Therefore, we can replace our single quote with this particular number 1, 2, 3, 4. So we are going to do the same kind of reconnaissance again, which is union select table name from information underscore schema dot tables. Okay. After we ran this, the same result as challenge 1 come back. We still have the SSN table, we still have the user tables. So now, because just now, what we ran to check the columns can't be used anymore. Because just now what we did was union select column underscore name from information underscore schema dot columns where table underscore name is equals to SSN. This is our previous code from our challenge 1 where we do our reconnaissance. If we were to inject this particular code in, you can see that it says that unknown column SSN in where clause. That is because it has removed the table name equals SSN. So it doesn't recognize SSN as a string to identify that particular table. What we can do around it is that since we learn database management system, string actually accept both single quote and double quote. What we can do is we just include a double quote to identify that SSN is a string, and we can inject it again. So after injecting, you can see that our normal result came back, which is the name as well as the SSN. So we are going to use the same command that we have previously, which is union select name from SSN, run it, we get our result from the username, okay, the name of the users that are identified in the SSN table, as well as our key thing, which is the social security number, the SSN from here. So because of how it's actually indexed, because we did not do any order by, therefore it's actually ranked by their index in the table itself. So again, in our report, we have actually included the matched version of name to the SSN number. So now we are going to complete the last challenge, which is challenge 3, death row. So we see over here the instruction for challenge 3, death row. It's very similar to challenge 1, SQL Injection 101, but it only provides one row of output. To make things more challenging, this challenge configuration doesn't show us the query. So now, since we have attempted challenge 1 before, and we already know the query, it doesn't matter if we know what is the query. Or rather, even if we don't know the query, we can still try to test it out, because this is what black box testing is all about. So let's see the parameter. It is a select query. It has the injection type of where clause, there's no sanitization, and there's only one row being shown. Verbose errors are shown, but queries are not. So let's us try what we have keyed in our first challenge, which is single quote or 1 equals to 1 hash. Let's inject it. We can see over here is that there's only one return, which is username hurtdepper. Okay. So instead of going one whole round and we go and repeat again the recognizes process, because we know that it is the same as challenge 1 where our recognizes process we already done, we're going to jump straight into tackling the issue, how we're going to solve this single row issue. So let's now try our standard union procedure, meaning to say union, select SSN from SSN. This statement is only being injected because we assume that the table structure is the same as challenge 1, because that's what our instructions actually say. It is very similar to challenge 1, with the exception that there's only one row being shown now. So we're going to inject it. And you can see over here is that please ignore the fact that the query actually comes back out because it's not supposed to, but because we didn't went back to challenge and come back again, that's why the query actually is being shown. So now you can see that the result is actually only one row. So this is very troublesome, because with only one row, we cannot go into the second row, third row, fourth row, and read off the data. Every single time this query is ran, the first result of the table will actually be returned to us. So after searching on the net, realize that there's this function called group concat, also known as group concatenation. What we're going to do here is that we are going to use this group concat. That means to say group underscore concat. We are querying the SSN column of this. But then in order for the code, or rather the result, to be extremely organized, we are going to use a separator. So we're going to say separator. And we are going to use a comma. Okay? Because this is a string, okay, because of the single quote. And it uses a comma and a space bar as a separator from SSN. As per usual, we're going to inject it. And you can see over here now, we see one row, but there are multiple numbers coming back out, which in total, if we read it, there's 5 results, 1 result, comma and our space is our separator, 2 result, 3, 4, and 5. So since we have 5 results, we can also use this and change it to name. Inject it again. We'll still have the same 5 name in the same 5 order that we have in the previous challenge. So, by matching the 5 name to the 5 SSN number, we will actually get back the matching result that we get in challenge 1. Thank you for watching. I hope after this video, you will know more about SQL injection. See you next time.